Welcome all of you. So, previously we saw what are the different steps in analytic hierarchy process. Today let us take one mathematical example and we will also see like how each of those steps are applied for this numerical. So, let us assume it is a hypothetical numerical, okay, but based on the real world scenario. A city wants to select the best renewable energy technology for its upcoming 50 megawatt clean energy project, and the three alternatives for that city are solar PV, wind, biomass. Okay. Then the decision has to be made using HP based on the four criteria. The four criteria that are of importance to the municipal corporation of that city as cost, emissions, reliability and requirement of land. So, this is a generic numerical, like there are three types of renewable energy sources. Objective is to make a setup of 50 megawatt clean energy project. So, which of the renewable energies to choose and based on which criteria the decision would be taken. Okay. So, when we have these three things wind, solar and biomass, you can visualize there are different components of environment as well as energy and economy which deals with all three sources of energy. For wind, you will need a huge land area to set up these huge wind turbines. Before that, you will also need the wind availability in that region. For solar, again we will need the solar radiation and then lot of area for installing solar PV panels, because the efficiency for solar energy is not very high like coal power plants, or even wind has higher efficiency than solar energy, but then it is a renewable energy, and if there is enough sunlight and enough area to install those solar PV panels, it is a great alternative. Third is biomass. It can come from gardens or nearby farms or animal waste or the organic portion of the municipal solid waste, and it can be converted to power either through biogas route or through gasification route. Okay. The efficiency would be higher, but then the supply chain, the logistics, the storage, there are so many issues related to biomass, then cleaning of gas. So, there are so many parameters on different domain for each of these energy sources. Though all three are renewable sources, they would differ significantly under different criteria. So, if I ask you like just list down how many criterias would be important to make a decision like which one of these to choose. So, some of the criteria can be waste generation or byproduct generation, job creation, that is employment, technology maturity, reliability, then the cost obviously, and costs are of two types, operating and capital and operating and maintenance cost. Capacity factor, the 50 megawatt plant is a huge plant. So, at what plant load factor or capacity factor these plants are going to operate, those would make a difference. Requirement of land, because it is in the city we are talking about, the emissions, resource availability, whether do we have all these three resources available or not, grid stability, social acceptance, water use, scalability, and there can be many more criteria. Okay, you can go on listing down, but just for the sake of this numerical, we have chosen only 4 criteria for these 3 alternatives, and for those 4 criteria the data collected from the experts are given here. For cost, emissions, reliability, land requirement, it is 1, 5, 3, 1 by 3. So, cost is equally important with respect to cost, emissions 5 times more important, reliability 3 times more important, land requirement is 1 by 3 times, means it is less important than the cost. So, that is first column of the matrix gives you the data collected from the survey or the questionnaire. Similarly, for each of the alternatives, for these 3 alternatives, under these 4 criteria, these are the data collected. So, for cost, these are the importances or preferences, for emissions, this, for reliability and for land requirement. So, if you look at just like take an overview of this data, it is easy to tell under each criteria which technology is better. So, from here you can see cost wise solar is better, emission wise wind is better, reliability wise biomass is better, and land requirement wise again biomass is better. So, biomass because we are talking about municipal solid waste or something which is generated on a daily basis. So, there is reliability or that is always available. Wind and solar are intermittent, okay. Then and they won't be available throughout the day. Land requirement would be less because it is a concentrated solid fuel kind of resource. compared to, and for wind we will need wind farm, for solar also we need huge land area. So, in reliability and land it is obviously biomass which is better, but then in other criteria something else is better. So, it is a complicated problem and we need to solve it using some systematic approach of AHP. So, let us start with the pairwise comparison matrix. The solution starts with pairwise comparison matrix for criteria. How many criteria are there? 4. So, matrix will be of how much? 4 by 4. So, cost, emission, reliability, land requirement, we just prepared a matrix and there are 16 elements or 16 cells. Similarly, for 3 by 3 matrix, how many cells will be there? 9 cells, right? So, for 4 by 4, we have to enter these 16 cells. The given data comes into the first column 1, 5, 3, 1 by 3. That was the data obtained from the experts or judgments or the literature. Next step would be you can fill the diagonal element as 1. Now, this is going to be reciprocated here. So, it is 5, so it is 1 by 5, 3 becomes 1 by 3, 1 by 3 becomes 3. Now, this is fine, 1, 1, 1 is fine. Now, how did we get these two numbers? Okay, because based on these two or these 3 numbers, the remaining 3 entries would be filled, right. So, as I told you, like if we follow the scale of 1 by 9 to 9, so you can shift the equivalent number of spaces based on the upper value. So, when you go from one row wise, when you go from 1 to 1 by 5, it is a 4 level shifting, 5 to 1 again 4 level it is shifting down, 3 to 1 by 3. So, 3, 2, 1, 1 by 2, 1 by 3, that is how the scale shifts down. So, again 4 spaces. Okay. So, since 5 to 1 it is 4 spaces down. So, when you go 4 spaces down from 3, you will get here 1 by 3. When you go 4 spaces down from 1 by 3, you will get 1 by 4, 1 by 5, 1 by 6, 1 by 7. So, that is how you got the numbers 1 by 3 and 1 by 7. The moment you get these entries, you take their reciprocals and fill these missing values. Now, how do we get this value? Again, from 1 by 3 it goes to 1. So, from 1 by 7 it goes to 1 by 5. You just go on the 2 step down, 1 by 3, 1 by 2, 2 step up. From 1 by 3 it is 1 by 2 and 1. So, from 1 by 5 it will be 1 by 6, sorry 1 by 7 it will be 1 by 6, 1 by 5. So, when you fill 1 by 5 you get the reciprocal of it as 5. The next step is sum of the columns. So, 1, 5, 3, 8, 1.3 that is 9.3. You do the sum of each columns. Now, the thing which I just told you, we have written it here step by step. So, once the data is given to you, how do you fill pairwise comparison matrix, and then you will check the consistency of it. Okay. But if the data is available column wise, while making pairwise comparison matrix, if you follow these procedures, most of the time or almost all the time, it is going to be consistent. Okay. So, first you fill the entries in the first column from obtained data, just like we had it now for 4 criteria C1, C2, C3, C4. You had some numbers here, right, 1, 3, 5, 1 by 3. Now, once this first column is filled, convert value in the first cell of matrix to 1 if it is not 1. Now, in this case it happened out that this value is already 1. If it is not 1, if it is something else, like when I say C1, C2, C3, C4, if these are the 4 criteria and suppose here value is 5, 3, 1, 2. These are the numbers which we got from the survey. So, the value is not 1, the first entry into the column, then how do we convert it to 1? There are different ways. One simple way is either you divide it by 5, you divide all the numbers by 5 and you will get this value as 1, but then these will be little different numbers like 3 by 5, 1 by 5 and 2 by 5, it does not matter. Okay. The approach would be correct mathematically. Other way is either you shuffle it, because see one of the entries is 1. So, maybe you just take this criteria here and bring this criteria here, but then once you change the order of the criteria, stick to the new order throughout the numerical. Okay. For all the cases you have to follow the same order. The third way is to shift the positions using the scale of AHP. So, first you may do it by equal shifting first column values using AHP scale up or down. So, if we have to make 5 as 1, you go 4 down the scale, right. So, 3 will also go 4 down the scale. So, it will be after 1 it is 1 by 2, 1 by 3. From 1 you will go again 4 scale down, how much it would be? 1 by 5. From 2 it will be something like 1 by 4. So, now these are your new values for the data for 4 criteria, where you see the first entry is unity 1, because when you want to prepare the pairwise comparison matrix, you need diagonal elements to be 1. That is why these are 3 different ways to convert that value to 1. You can shuffle the entries, but then stick to the same sequence. You can divide by same number to make it 1. Now, next step is enter 1 in the diagonal cells of matrix and fill reciprocal values in the first row. That's similar to what we have been doing so far. Once you get this number as 1, you just enter the diagonal elements as 1 and take the reciprocal values and enter the missing values using this AHP scale shifts. Using this AHP scale shifting is is rational, and it's easy, it's simple and easy to understand. Okay. So, preferably use this shifting of numbers using the AHP scale, so that you can fill all the values rationally. Now, going back to that previous numerical, once we get the column wise sum. So, this was the criteria, 4 criteria compared amongst each other. You do the normalization of that matrix. How did we do the normalization? You divide each entry in this column by 9.33. So, it will be 1 by 9.33, 5 upon 9.33, 3 upon 9.33 and 1 by 3 upon 9.33. So, these numbers will give us a normalized matrix for this. Similarly, do it for each of the 4 columns. Okay. So, that will give you this matrix, the normalized matrix for cost, emissions, reliability and land requirement. So, you took the column wise sum, normalize each entry into the matrix column wise, and now take the average row wise. So, average of these 4 numbers will give you the final weight. So, now the 4 criterias have got the weightages of 0.12, 0.55, 0.26 and 0.057. So, what do you understand from here is, obviously this is the most important criteria, which is emissions, followed by reliability, followed by cost, and last important criteria is the land requirement. But now, this is what the matrix which we have got, and this is the approximation method through which we got the final weights for the criteria or the priority vector. Next step is to check the consistency, whether what we have got is based on consistent data or not. So, check for consistencies. Ax equal to lambda x, where A is the given matrix, x is the weights that we calculated for criteria, lambda is the eigenvalue and x is the same as this x, the calculated priority vector. So, A matrix I have written it the original form. Okay. This is not the normalized one or the averaged out one, the original matrix which we had prepared using this diagonal elements 1. Okay. So, you have that matrix 4 by 4 matrix for criteria. This x is the criteria weights that we calculated in the previous step. So, those weights are there, and Ax equal to, so when you multiply this A into x, how do you multiply? Rows into column. So, how do we get this number 0.492? It will be 1 into 0.122 plus 1 by 5 into 0.558 plus 1 by 3 into 0.263 plus 3 into 0.057. You do the summation, you will get the value as 0.492, that is this value. Similarly, you take the second row and multiply with this column, you will get 2.3. Third row into the entire column, fourth row into the entire column will give you the value of Ax. So, you multiplied this 2 matrices you are multiplying, right. One is 4 by 4 and one is 4 by 1. So, you get 4 by 1 as the product. This is Ax equal to lambda x. So, Ax equal to lambda into x, x is the same. So, you can calculate the eigenvalue now. Lambda would be just 0.492 divided by 0.122. You divide all these 4 numbers by these 4 values. So, you will get a lambda vector having 4 values. Okay. So, the 4 values which you get are 4 point something. You take the by doing this kind of division. Each of these 4 values will give you the maximum eigenvector, that is 4.118. You just do the summation of these 4 and divide by 4, it will give you the average. So, this is the lambda max values which is required for checking the consistency. Once we have this lambda max values, the next step is checking the consistency index. Lambda minus n by n minus 1 equal to 0, n is equal to 4 here. Lambda was something 4.118. So, how much consistency index comes out to be 4.118 minus 4 upon n is 4 minus 1. So, if you do this 0.118 divided by 3. So, it is a very small number 0.039. Now, next step is consistency ratio. For that we need random index. So, random index for 4 by 4 matrix is 0.89, it is known from that static table. So, you have this consistency index 0.039, you divide it by random index to get the consistency ratio, it comes out to be 0.04, it is less than 0.1. So, it means the consistency of this matrix is acceptable, clear. So, the final criteria weights what we calculated are acceptable, those were like this. Now, from this you can say now the most important criteria is emissions, followed by reliability, followed by cost, and least important criteria is land requirement. So, this is the first major first half of the problem that we have solved. We had been given 4 criteria, 3 technologies which we have to compare, but first of all we need to know among the 4 criteria which criteria is more important. So, for that we did this pairwise comparison matrix thing, checked for its consistency, and then finally reported the weights or priority vector for each of those 4 criteria. So, next step is under each criteria we have to calculate the alternative weights. Okay. So, using that tabulated data that was given to us, first it was given for criteria which we have used and got the weights for or importance for the criteria. Now, in addition to criteria data, if you remember, for each criteria like this solar, wind, biomass, these are the technologies, and the data for each of these criteria C1, C2, C3, C4 is given to us. Okay. So, we will take one criteria at a time and compare these 3 in the form of 3 by 3 pairwise comparison matrix and repeat the same activity that we did for criteria, and finally we would get the values for alternatives. So, this next step I think should cover it in the next class. So, today we will stop here. Thank you.